As we can see from the diagram here, we have an 8 dip switch pack here, and right next to it we have a 10K resistor pack that's isolated. Now notice up here what we have is we have D12, 13, 14, and 15 connected here along these pins, and then the resistor pack connected this pin here to pin 1, the next pin here to pin 2, and so on along here. Now when we run our program, let's take a look at our program. We can see here that BusIn, which is our switches now, has got D12 as the most significant, which is this is most significant, this is the least significant here. So when we run our program, we're using BusIn to grab the information from our dip switches, and we're using BusOut to send all of this information to our 7-segment displays. Now if you look here, we have a couple different ways to hook these up, and what I've done is I've connected these 4 connections to 3.3 volts. I've connected these 4 connections here to my switches to ground, so we're using them as pull-ups. So as I flip through each one of these combinations, what we're going to see is switches is going to take a value from 0 to F, because that's all we can do with 4 switches, 0 to F. Right now we're getting a pattern for 0 because all of our switches are in this position. But as I start flipping my switches, I can get different patterns to come up. I can get 1, I can get 7, I can get F, and just by changing this I can go through any possible combination of these 4 switches. And what's happening is this value here is being put in as the index to this array. So in this case we have A coming in from switches, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A. So this is the pattern that's going to be sent. So based on our switches, it's going to send this pattern to our 7-segment displays and put up whatever pattern happens to be here. By running this program, this is the quickest way to check out your switch interface.